Well, causal diagrams allow you to diagram juggling patterns. Anything from a one-person pattern to a 10-person pattern or whatever, any number of people with any number of hands. And it allows you to do it in a very concise way so that any juggler in the pattern can look at one line in the picture and see what he has to do. Doesn't have to learn everybody else's part. And overall, you can see interesting patterns going on within the pattern, interesting combinations of throws. So it's very easy to see from a diagram, causal diagram, how a pattern goes. It's also very easy using the diagram to record a pattern, just give it to somebody else, or for posterity or whatever. In 1988, I was trying to figure out how to do a 7-club version of the 6-club 3-count. And so I started writing down, and being a scientist, I wrote down hands from, I had time flowing from left to right on a piece of paper, basically as like a graph paper, but it was just a piece of paper in my notebook, and I wrote down rights and lefts and said, okay, how do we make this work? I didn't at that time actually draw the lines that I use in causal diagrams these days, but I drew I drew the hands at the moments they make their throws, and tried to figure out how to make it work. I used numbers instead of lines, so I would write 2 for a double, and you had to figure out that a double came down to actually 2.5 counts later in this case, so I used that notation to figure out how to create a 7-club 3-count. That was in 1988. And I know that because I taught my notes show that I taught the 7-club 3-count at the 88 Bradford EJC. And I'm sure I did it before that, but not too much before that. I think that's pretty much within a month of when I created it. And created this sort of basic causal diagram, which wasn't the full-blown version. It didn't have arrows in it. It was really to work out patterns that I had an idea about. I would want to come up with a pattern, I don't know, that was a pass-pass-self pattern with 4 people or whatever, and I couldn't remember in my head what all 12 counts or whatever were going on. So I would write it down. Mostly I used the causal diagrams to develop patterns that I wasn't sure would actually work. At one point I theorized that there were, based on my 7-club 3-count, that there would be an 8-club 3-count, and I told someone, okay, we'll do it like the 7-club 3-count, but do this. It turned out I was wrong, and when I went to write down on paper with a causal diagram this pattern, it turned out it was an 8-club pass-pass-self, not an 8-club 3-count. Not really. I mean, it's a very simple, very simple notation. The only non-obvious aspects of it, as far as I'm concerned, are the hold, where you don't make a throw. What happens? What does the diagram look like if you hold a club in your hand and don't make a throw? Or if you have an empty hand, those symbolisms in the diagrams are perhaps less obvious than everything else. But everything else is just completely plain to me, and I didn't feel like, okay, we have to say, this means that. It just was completely obvious. It's just right hand throws to left hand throws to right hand throws to left. That's it. Goes on. That's the whole diagram. I mean, it starts and ends. There's one cycle of it. So I would typically put little vertical bars here to show when it starts over. So you just do this and repeat it forever. I don't do solo juggling. How does a 4-ball fountain work?
It's 2 in each hand.
It is. You want them out of sync, huh? So the right is throwing to the right, and the left is throwing to the left. That's pretty much it. And it goes on. As a general rule, the length of the arrow plus 2. Side swap value, so in this case, this arrow length is 1, so that's an arrow of 1, but it's a side swap 3. Well, the arrow length nominally tells you how long the object is in the air, relative to the speed of the pattern. Of course, the speed of the pattern can be fast or slow, and the arrow doesn't change. But as number of spins, yes, I mean, as I'm saying, the number of spins is essentially the same as the length of the arrow. So if you have an arrow of length 1 or even 1.5, it's probably a single. You could do length 1.5 throws as doubles. That would be a little different. That would be a slower pattern. But typically, we would do the other way. We would round down, dropping a half arrow length. So yeah, a length 1 is a single. A length 2 is a double. So that gives you the normal double fountain pattern here. Of course, you can do this exact pattern in singles, and you can't tell from this drawing whether someone's doing it in singles or not. So we'll use these patterns I've already got here on the board. This is an interesting pattern. This is the 4-count simul feed, in which the feeder has a very couple of awkward beats here, and then there's just sort of a 4-count going on in between passing beats. On the passing beat here, the feeder makes 2 throws at once, like so. Left hand throwing to this person's left hand, right hand throwing to this person's left hand. And then he has on the next count, he has 2 incoming clubs, 1 from each of these people. Otherwise, they would have too many clubs. So he catches 2 at once here, and then he just does a 4-count, the 3 selves here. But this transition right here and right here require the feeder to hurry. In order to make this throw, for instance, we look at the second cycle, or the second half cycle. To make this throw, the feeder just made a right-hand throw on the previous count. So he has to make 2 right-hand throws in a row, and so that's what I call a hurry. So this is a hurried throw. This throw is not hurried at all, it's just normal. So half of the feeder's passes are always easy, and the other half are always hurried. So on every passing beat, the feeder has 1 hurried throw and 1 not hurried throw. He also has a hurried catch. This catch here is a hurry. Well, he has to catch this. It's a hurried self, actually, because he just made a right-hand throw. He has to make a right-hand throw again. Over here, he has to make a left-hand throw again. This particular pattern alternates. It's nicely symmetric for the feeder between a right-hand hurry there and a left-hand hurry there. Wherever you see wherever you see right, or left, you get a hurry. So the feeder has right here, and over here, the feeder has left as far as throws go. So those are hurries. That's, I can define it that way, but I define it as feeder has to hurry. And it turns out if you have to make the same hand throw twice in a row, you have to hurry. So yeah, it's the same definition either way you look at it. In side swap, there's really no way of notating. In normal plane side swap, there's no way of notating a hurry. This is the first pattern I came up with using causal diagrams. And at the time, I say I wasn't actually using the arrows, but I was think of these as arrows rather than just lines. But I wrote this thing without the arrows, and I would write 2 up here and 2 down here. This is a self. So that I would write pass, self, pass, and I would write a superscript over the P for what it was, a double or whatever. This is a good example of a 2.5 length arrow, which is nominally would be a 2.5 spin throw, but that's inconvenient for passers, so we do that as a double. You can also do this pattern as singles. It's a very interesting pattern in singles, in which case it becomes very syncopated, and you really can't keep the even rhythm within one person here. But that's the 7-club 3-count, which back in the 90s I was saying, because I had invented it just before the 90s, I was calling this the pattern of the 90s. I still think of it as the pattern of the 90s. Not that many people learned it, but it's a beautiful pattern. You would write the number for this pass, for this club, for when it gets thrown again, and it gets thrown again down here, which happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9 counts later, or half counts, depending on how you look at this. So that would either be a 9 or a 4.5. So the pattern is really 9, 6, 6, and for the other person, 6, 9, 6. It's really the same pattern. Or some people like to call it 4.533, which is sort of more friendly to thinking of the cells as 3s. Either way, it's the same pattern. I did know side swaps, but I didn't think of the fact that there was this sort of one-to-one, in some sense, one-to-one correspondence between the throws. And I didn't think of, when I drew this diagram originally, I didn't think, okay, this is going to be a 6 or a 9 or a 7 or 4.5. I just said, here's a diagram. I didn't think of it numerically at all. I thought of it on a time scale, just sort of a continuous flow of time. And, later I looked at it and said, well, okay, I guess you would have to call this a 9. And that's what I would call it, a 966. But no, I didn't identify that with site swaps. And I don't think site swaps helped me. I did know of site swaps. I don't think it really had any help in my invention of the notation. It was just basic site swaps in those days, and there was no real passing notation for site swaps. I hate ladder diagrams because, if you look at this pattern here, sorry if I'm rolling on camera. If you look at this pattern right here, this is so simple, especially when you take away all the little scribbles I made around it. But on a ladder diagram, you can't even see that this is the pattern if you look at the ladder diagram for a cascade. It's just so complex because it shows all the balls or clubs or whatever at any given time. So it's very, very messy to look at and hard to read. Whereas, these are fairly complex patterns. But if this person wants to look at this pattern and say, how do I do this? He just reads across here. He says, pass, self, self, self. Pass, self, self, self. I'm alternating right and left. Now, that's it. In about 5 seconds, he knows exactly what to do. The feeder has a little more complicated pattern, but again, this is a very complex pattern. But in the 7 club 3 count, very easy to read the pattern. It's visual. You can look at this, and you hardly even have to think. You can look at this and say, okay, something. Even if you don't even know this is a passing diagram, you can see there are patterns, regular patterns here, and something regular is going on. And if I tell you that this is one person, and that's one person, you'll say, well, okay, this guy's obviously doing rights and lefts, and this guy's doing something funny here, but I don't quite know what that is, but this is much simpler. You can look at this and figure that out. If you try to write this in multi-hand notation, in site swap notation, which I have to say I'm not a master of because after all I created this, I've been using this, so what do I need it for? Multi-hand notation is just not useful unless you're limited in communicating with someone by only letters and numbers and no drawings. Okay, if you have to do it in ASCII on rec.juggling and you can't even draw pictures, which you can do with ASCII, and I've drawn pictures like this with ASCII, then you might have to, but it's so much easier. It's even easier to draw a picture with ASCII than it is to figure out the multi-hand notation for it. Let's say this, somebody tell me what this notation is and what this is in multi-hand notation. There are a number of patterns that I wanted to do and I didn't know how to put them together. I wanted to do, and I can't, off the top of my head, other than this pattern, certainly falls in that category. I wanted to do a 7 club 3 count. I didn't know what it was going to look like. And I've created a lot of patterns. One night I set out to create all the 1 count feeds that are possible with certain restrictions. 1 feeder, 2 feedies, a feeder is passing on every count. All the possible combinations. And I did that by drawing 56 causal diagrams. And the next Wednesday night at Stanford, we juggled 28 of those. And we got through all of them. It took us a couple hours. I could not have come up with those patterns, and I certainly couldn't have remembered them without the causal diagrams. Maybe you could have written some numbers down, but the causal diagrams instantly let me, see what we're doing. 4 or 5 of those were known patterns. Most of them were not. Most of them probably haven't been done since. That's a great philosophical question to which a juggler has no need to answer. On the other hand, in the history of juggling, I'm sure that many people have invented the same pattern independently over and over. I think we already know that different people invented site swap notation itself independently, identically. And I'm sure that many people invented, let's say, the 6 club 3 count. I don't know how many people have invented the 7 club 3 count. I think it's a much smaller number. But I'm sure that people have invented these patterns over and over. And I doubt that anybody else has invented this one. It's just too obscure. But the patterns were there waiting to be invented. Did they already exist? No, they were just waiting to be invented. They're causal diagrams because each arrow shows, each throw in juggling causes the next throw, basically. And so in the case of causal diagrams, each arrow causes another arrow. Juggling continuously causes juggling to continue to happen. Let me show you on the board. Here's a normal three count, two-person, six-club three count. And when this pass comes over here, it causes this guy to have to do a self just to make that catch. And his self causes his other hand to have to do a self to make that catch. And that causes this pass, that causes this pass, and so forth. In the diagram, there are these causal lines that run all the way through, connected by the arrows. In this particular pattern, there's two. And if you cut a line, vertical line through here, you'll cut each of those once. And so there's two causal lines, four hands, that's a total of 6 clubs. In this very odd pattern here, there's also a bunch of arrows going through, only this one is a backward arrow. In this backward arrow of two counts in length indicates an empty hand over here. This, in a sense, this empty hand causes this double to happen. And this double causes this empty hand. They're sort of feeding on each other here, back and forth. So that's perhaps not completely clear, but in a pattern like this, where we have a hand across, again, an arrow going backwards 1 count, this throw forces that hand across, because this hand had to get rid of this club. And so it made this hand across, and then that hand across. This throw actually comes before the hand across, but this hand across forces this throw. Even though the hand across comes after it, that hand across forces this throw. So the causality actually goes backwards in time. Of course, no events go backward in time, just the causality. Again, the causality here is going backwards in time by 2 counts. Normally, it's not so conspicuous, so odd as that, but this throw really does cause that throw, which causes that throw, even though this throw is before that one. It was, early 90s. When you say term, I mean the term causal.
Yeah, the term causal.
I don't remember exactly when I came up with that name, but I don't remember, I never used any other term for it, and that, when I thought of that, it was just completely obvious that that is what it had to be, because what's happening here is, in juggling, what happens in juggling is every throw causes another thing to happen. And if it didn't cause it, we wouldn't do it, and we often don't, and it doesn't happen. So it's having those causes, those extra clubs, extra balls, whatever, in the air.